Right now, sitting inside the moon, there's a layer of rock that should not exist. It is warm, it is partially melted, and according to every model we had before, it should have gone completely cold and solid over 1 billion years ago. Nobody predicted it. Nobody was looking for it. And when the numbers first came back, the scientists running the analysis assumed they had made a mistake. They had not. And that discovery is only the beginning of what I am about to walk you through. Because underneath the ground you are standing on when you look up at the moon tonight, there are caves wide enough to swallow entire neighborhoods, quakes strong enough to trigger landslides and ice fields, that may hold enough water to fuel every rocket humanity launches for the next century. Stick around, because the strangest part of this story is not even about the moon. It is about a hole on Mars that scientists now believe dropped straight down into one of the best places in the entire solar system to search for alien life. And I am saving that for later, so do not skip ahead. For decades, we were taught the same tired description of the moon in every textbook in every classroom. A dead rock, a frozen, silent, geologically finished ball of gray dust and craters that stopped doing anything interesting nearly 3 billion years ago. No atmosphere, no weather, no activity, nothing left to discover. Just a rock circling our planet, tugging on our oceans, and doing absolutely nothing else. That description has now been proven wrong in ways that are reshaping NASA's entire plan for the next 10 years of exploration. The people who figured this out were not staring at old Apollo photographs. They were using instruments more advanced than anything that has ever been pointed at the moon before. And what those instruments picked up changes almost everything we assumed about our closest neighbor in space. Let's start with something simple: temperature, because it explains almost everything else that follows. Stand on the lunar surface during the day and the temperature around, you would sit near 120 degrees C, hot enough to boil water instantly. Wait for the sun to set, and within hours, that same spot drops to roughly minus 130 degrees. That is a swing of about 250 degrees between day and night, and it repeats itself month after month for billions of years straight. Do that to any solid material long enough, and you get exactly what you would expect. It cracks. It weakens along its natural fault lines. Whole sections of surface eventually shift, slide, and sometimes collapse inward. NASA's Lunar Reconnaissance Orbiter, spacecraft that has been mapping the moon in incredible detail since 2009, has already spotted thousands of small cliffs called lobate scarps scattered across the surface, essentially fault lines where the crust has buckled under pressure. What makes these scarps genuinely alarming to planetary scientists is that plenty of them look geologically young. On a world that is 12 billion years old, something that formed within the last 50 million years counts as almost brand new. And a large number of these scarps appear to fall into exactly that category. That tells researchers the moon's crust is not just carrying old scars. It is still under active stress right now while you are watching this. And we have direct proof of that stress sitting in data that has been quietly waiting since the 1960s. Seismometers left behind by Apollo astronauts recorded something that genuinely startled the scientists monitoring them. Real moonquakes, some reaching a magnitude of 5, strong enough to shift loose surface material, knock boulders free from slopes, and trigger small landslides in areas that orbital images show are already unstable. When researchers recently reran that decades-old Apollo data through modern computing tools, several of the fault lines responsible for those quakes appeared to have been active, surprisingly recently in geological terms. A world that looked completely still and silent from Earth turns out, once you look closely enough, to still be quietly moving. You can actually see this in the orbital photographs. Certain slopes show fresh, sharp-edged material that is clearly slid downhill recently, standing out dramatically against the older weathered ground around it. In a few images, it genuinely looks at first glance like a chunk of the moon simply broke off and slid away. What you're actually looking at is loose surface dust called regolith sliding downhill in response to moonquakes, savage temperature swings, or the constant hammering of tiny space debris that slowly loosens the upper layer of dust and rock over millions of years. Since the moon has no atmosphere, even microscopic particles from space slam into the surface at full speed with nothing to slow them down. And over billions of years, that endless bombardment has left the top layer fragile and prone to sliding whenever something else nudges it. This matters enormously for the Artemis program, NASA's active plan to send humans back to the lunar surface and eventually keep them there long term. Figuring out which patches of ground are actually stable and which ones only look stable in old photographs, while hiding active fault lines underneath, is not some academic side question. It is a direct safety issue for astronauts. And that brings us to something even stranger than the shaking surface, because what is happening below ground on the moon is arguably a bigger deal than anything happening above it. In 2024, a research team studying gravity data from two NASA missions, GRAIL and the Lunar Reconnaissance Orbiter, uncovered something nobody had predicted going in. GRAIL flew two small spacecraft in close formation around the moon back in 2012, and as they passed over regions with slightly different gravitational pull, the two spacecraft would drift almost imperceptibly closer together or further apart. By measuring those tiny shifts in distance with extraordinary precision, scientists mapped the moon's gravity field in more detail than ever before, and used that map to infer what was happening deep inside the moon in a place no camera will ever reach. Their models simply could not match the real gravity readings unless they added in a softer, partially molten layer sitting between the solid rocky mantle above and the metallic core below. Without that layer, the numbers refused to work. The gravity data demanded it exist. The research published in the journal AGU Advances suggests that layer is made largely of a mineral called ilmenite rich in titanium and iron oxide, and that this mineral might be exactly what is trapping enough heat to keep the layer molten. Here is where it gets genuinely interesting for anyone thinking about long-term lunar bases. Titanium is one of the most valuable materials in modern engineering, prized for its combination of extreme strength, low weight, and resistance to heat and corrosion. And it shows up in aircraft parts, spacecraft frames, medical implants, and high-performance machinery. If the moon really does contain a titanium-rich molten layer, that is a potential resource sitting right there for any future permanent human presence. And pulling raw material directly from the moon would be dramatically cheaper than hauling the same material up out of Earth's gravity well, which remains the single most expensive part of any space mission. But here's the mystery that this discovery immediately created, and that scientists still cannot fully answer. How is that layer still partially liquid at all? The moon is 4.5 billion years old, and it should have lost the vast majority of its internal heat by now. Its core is far smaller relative to its size than Earth's, meaning it generates far less internal heat to begin with. And yet, something down there is still keeping that layer soft and partly molten billions of years after the moon was supposed to have frozen solid all the way through. Researchers suspect the titanium and iron oxides in that ilmenite layer might be unusually good at trapping and holding on to heat. But exactly how it has stayed warm for this long remains an open question that follow-up studies are actively racing to answer right now. Keep that question in the back of your mind, because it connects directly to something waiting for us at the polls a little later in this video. For more than 50 years, scientists suspected the moon might be hiding underground tunnels, hollow tubes carved out long ago by ancient lava, flows during a period when the moon was still volcanically active. The logic came straight from studying similar features here on Earth in places like Hawaii and Iceland. When lava flows across the ground, its outer layer cools and hardens while the molten interior keeps flowing through the middle. Once the eruption ends and the remaining lava drains away, the hardened shell is left standing, empty, a hollow tube. On Earth, these tubes typically run a few meters to a few tens of meters wide. On the moon, where gravity is only 1/6 of Earth's and ancient eruptions were far more massive, the same basic process produced tubes on a completely different scale. In 2024, researchers from the University of Trento in Italy confirmed something extraordinary using radar data beamed down and reflected back from underground structures beneath the Mare Tranquillitatis region, the exact same area where Apollo 11 touched down in 1969. What they found was a cave at least 100 meters deep and potentially hundreds of meters wide, likely just one of many similar structures scattered across the lunar surface, all remnants of the same ancient volcanic system. For future human exploration, this matters enormously because a natural underground cave provides something no surface structure can easily match: automatic protection from radiation. The lunar surface sits fully exposed to solar radiation, cosmic rays, and constant micrometeorite impacts, meaning any surface habitat would need heavy, expensive shielding just to keep its occupants safe. A cave cut into solid rock already provides that shielding for free. NASA's own measurements show that areas just below the lunar surface hold a remarkably steady temperature around 17 degrees C, no matter what wild extremes are happening up above. On a world where surface temperatures swing by 250 degrees between day and night, a natural shelter sitting at a stable 17 degrees is an extraordinary find. And engineers are now seriously discussing building humanity's first permanent lunar base inside one of these lava tubes instead of out on the exposed surface. But even the safest cave in the world still needs water. And that is exactly where the story turns toward the lunar poles and toward the newest confirmation that only landed earlier this year. The moon barely tilts on its axis, roughly 1 degree compared to Earth's 23, which on Earth is what gives us seasons. On the moon, that near absence of tilt means the sun never climbs very high above the horizon anywhere close to the poles. And inside the deepest polar craters, sunlight never reaches the floor at all. Shackleton Crater at the lunar South Pole stretches more than 20 kilometers wide and plunges over 4 kilometers deep. And its floor has not seen direct sunlight in billions of years, sitting at a permanent temperature around 200 degrees C. In cold, that extreme and that ancient, any water that ever arrived there has nowhere left to go. It simply stays frozen, locked in place. Back in 2009, NASA deliberately slammed a spent rocket stage into one of these permanently shadowed polar craters and flew a second spacecraft straight through the resulting debris cloud to analyze what got kicked up. The result was the first direct confirmation of water ice sitting inside lunar soil. That is not where the story stopped, though. Earlier this year, in April of 2026, NASA confirmed something even bigger, drawing on newer orbital data and refined modeling built with international partners. The updated picture shows that water ice has been steadily building up inside these permanently shadowed polar craters for at least 1.5 billion years. Layer upon layer, essentially undisturbed since long before complex life existed anywhere on Earth. Current estimates suggest the total amount sitting frozen inside these craters could run into the hundreds of millions of tons, with some models pushing that figure into the billions of kilograms. This is not water sitting in a lake waiting to be scooped up. It exists as microscopic ice crystals mixed directly into the lunar soil, meaning any extraction process would require drilling into that soil and heating it just enough to release water vapor, then capturing that vapor before it escapes back out into the vacuum of space. The engineering challenge here is genuinely brutal, but the payoff would be enormous because water can be split into hydrogen, and oxygen using solar power, and hydrogen and oxygen happen to be rocket fuel. A lunar base sitting on top of a water supply like that could manufacture its own propellant, right there on the surface, turning the lunar South Pole into a refueling station for missions, heading much deeper into the solar system, since launching off the moon takes a fraction of the energy required to launch off Earth, thanks to that much weaker gravity. Now here's a detail that most coverage of this topic completely skips over, and it makes the South Pole strategy far more clever than it first sounds. NASA has identified specific ridgelines near the South Pole nicknamed peaks of eternal light that sit in near constant sunlight thanks to that same minimal axial tilt. And some of these ridges sit close enough to the permanently shadowed craters that running power cables between the two is genuinely feasible. Picture a solar farm perched on a sunlit ridge, an ice mining operation working in the frozen darkness just below it, and a crew habitat tucked safely inside a nearby lava tube for natural radiation shielding, all working together as one connected system. That is not science fiction. That is the actual working blueprint multiple space agencies are currently building toward. Artemis Tycoon, currently underway, already sent astronauts around the far side of the moon, making them the first humans in over 50 years to lay eyes on that hidden hemisphere in person and setting a new distance record for crewed spaceflight along the way. Artemis III, targeted for no earlier than mid-2027, is aiming to put astronauts down inside one of 13 candidate landing zones, all clustered within 6 degrees of the South Pole, each one bouncing enough sunlight for solar power against close proximity to those precious shadowed ice deposits. China is not sitting still, either, with its Chang 7 lander also heading toward the lunar South Pole this year, chasing the exact same ice deposits when multiple national space programs and private companies all converge on the same small patch of a world within the same handful of years that tells you everything about how valuable that ice has become. Now remember, that hole on Mars I mentioned at the very start. Here is where it connects. And honestly, this next part might be the most unsettling discovery in this entire video. Back in 2017, NASA's Mars Reconnaissance Orbiter photographed a stretch of Martian terrain riddled with small holes, most of them shallow depressions with dark soil visible under a thin coating of frozen carbon dioxide. One hole stood apart from all the rest. It was almost perfectly circular, roughly 100 meters across, ringed by a sharp crater edge. And unlike every other hole nearby, it appeared to drop straight down into an underground space of completely unknown size. Researchers believe a meteorite punched clean through a thin section of surface rock and accidentally opened a doorway into a much larger cave system beneath a cave that had almost certainly existed long before the impact ever exposed it, carved out by ancient volcanic activity back when Mars itself was geologically alive. Why does a random hole on Mars actually matter this much? Because of what caves represent for the search for life. The surface of Mars today is one of the most hostile environments for biology anywhere in the solar system. There is essentially no global magnetic field to block incoming radiation. The atmosphere is far too thin to offer meaningful protection. The surface itself sits dry and brutally cold. Anything that might have lived there billions of years ago, back when Mars was warmer and wetter, would have had an almost impossible time surviving on the exposed surface as it exists today. Underground, everything changes. Rock overhead blocks radiation. Temperatures stay far more stable. Any remaining water, whether frozen or in the form of salty brine, would be shielded from the extreme cold and dryness above. The exact same logic that makes lunar lava tubes attractive shelters for future astronauts, makes Martian caves the leading candidates for finding either surviving microbial life or fossilized traces of ancient life that vanished long ago. By 2019, NASA had already mapped over 1,000 potential cave entrances scattered across the Martian surface using orbital imagery alone. And the European Space AA's Mars Express mission has separately confirmed ancient lava tubes hiding beneath extinct Martian volcanoes, stretching that hidden underground network even further than any single photograph could show. There is one more Martian mystery worth understanding before we close this out, because it connects directly back to something that will matter for any human mission that eventually lands there. For more than 50 years, scientists have puzzled over roughly 2 million dark streaks running down slopes, crater walls, and ridges across the Martian surface. Long, thin lines that look exactly like something wet once trickled downhill and stained the rock beneath it. When these streaks were first photographed back in the 1970s, the leading theory for decades was that they were caused by brief flows of liquid water melting temporarily out of ice before refreezing or evaporating. That theory stuck around for so long, partly because liquid water was simply the most exciting possible explanation, and wherever there is liquid water, there is at least the outside chance of life. A recent study pulling together data collected between 2006 and 2024, covering more than 2 million individual streaks, finally ruled that explanation out. The actual pattern of when and where new streaks appear lines up far better with wind, not water. These streaks tend to form during periods of strong Martian wind in places where loose dust has piled up on a slope. Once wind speed crosses a certain threshold, it destabilizes that loose material, sending it sliding downhill and exposing darker, less weathered rock underneath, which shows up from orbit as a dark streak. It is essentially a dry dust avalanche, not flowing water at all, and the streaks slowly fade over decades as fresh dust resettles on top of them. What makes this finding genuinely significant is not just correcting an old theory, it is the sheer scale involved. That same study estimated roughly 80,000 brand new slope streaks form on Mars every single year. And combined with the millions already covering the surface, this process may be one of the single largest ongoing sources of dust in the entire Martian atmosphere. That dust affects weather patterns, surface temperatures, how much sunlight actually reaches the ground, and in the day-to-day conditions, any future human colony there would have to manage just to survive. Since dust storms have already threatened active rovers and dust buildup on solar panels remains one of the biggest limiting factors for any long-duration Martian mission. Put every piece of this together, and you get a picture of our two nearest neighbors in space that looks almost nothing like the one most people are still carrying around in their heads. The moon holds a partially molten titanium-rich layer that nobody predicted. Somehow still warm after 4.5 billion years, its surface keeps cracking and sliding under brutal temperature swings and genuine moonquakes. Underneath it all sit lava tubes wide enough to shelter entire future colonies, and at its poles, inside craters that have not seen sunlight since before complex life ever existed on Earth. There may be enough water ice to support a permanent human presence and manufacture rocket fuel for missions heading much further out. Mars, meanwhile, hides underground cave systems that may represent our single best shot at finding evidence that life once existed somewhere beyond Earth. While its surface quietly reshapes itself through tens of thousands of dry dust avalanches every single year, none of this sat in the textbooks a generation ago. Some of it was not even known 5 years ago. Every time we build sharper instruments and point them more carefully at these two worlds, they turn out to hold far more activity, far more complexity, and far more potential than the word dead ever captured. There's one more piece of this story worth knowing, and it connects the underground mystery of the moon to something the Apollo astronauts discovered the moment they got home. When those astronauts returned in the late 1960s and early 1970s, lunar dust had worked its way into every seam of their suits and equipment. Once that dust mixed with the oxygen inside the cabin, multiple astronauts noticed the exact same strange smell, something like burning metal, gunpowder, or fireworks. Lunar dust shares no actual chemistry with gunpowder, but every individual grain of it is sharp and jagged at a microscopic level, like tiny shards of broken glass. Because there is no wind or water on the moon to smooth those edges down the way ocean waves round out sand here on Earth. With no oxygen and no moisture at the surface, those particles sit for billions of years in a kind of frozen, reactive standby state. And the instant they finally touch oxygen for the first time inside a spacecraft cabin, they react immediately, producing that unmistakable burning smell. Engineers designing suits and habitats for future Artemis missions are actively working on ways to manage that same reactive dust. Because the Apollo experience proved it gets absolutely everywhere. And it is far more than a minor inconvenience for equipment seals and filters. The moon is not dead. Mars is not dead. And the closer and more carefully we look at either one of them, the more that keeps turning out to be true. Think about what that actually means for the next few years. Artemis astronauts are scheduled to walk within a few degrees of that ice-packed South Pole, standing above a molten titanium layer nobody expected. And beside lava tubes that could shelter the first permanent lunar residence in history, rovers on Mars are already circling those 1,000-plus cave entrances, deciding which ones deserve the very first close-up look for signs of ancient biology. None of this is speculation dressed up as science. Every claim in this video traces back to actual missions, actual instruments, and actual peer-reviewed data collected. Within the last 2 years, the gap between what we assumed about these two worlds and what we now know has never closed this fast before, and it keeps closing faster every single year as better hardware reaches both of them. If you made it this far, you now know more about what is actually happening beneath the moon and inside Mars than most people will ever bother to learn. And that is exactly the kind of story this channel exists to tell. If any single discovery in this video changed how you picture the moon or Mars, say which one in the comments, because I read every single one. Subscribe and turn on notifications so you catch the next update the moment new data comes in. Since both of these stories are moving fast enough that the next surprise could land within months, not years. Thanks for sticking with this one, all the way to the